Hello everyone, welcome back to our channel. In this session, I would explain how SSH works in detail through hands-on. In the previous sessions, we have already seen how SSH works in theory. Let us start. This is the server machine. We have already set up SSH server in this machine. Let me check the status. The server is listening on port 2222. And also, we have enabled here the password authentication as well as public key authentication. We can check the same from sshd config file. This is the file which contains various entries for SSH configuration in the server. So we have already established the public key authentication where the authorized keys file will be in .sh authorized keys file. So this contains the entries of authorized keys of all the clients. And also we have enabled password authentication as well, which accepts the password entries. So I have already created one user, which is test user. This user is created in this machine. So let us try to connect to this server from client using this user. So this is SSH client. So let me try to connect to the server on port 2222. So we have to use the target user. So I'm using test user here, and the server name is SSH server. So this V indicates the verbose option. So if we give 3 V's, then we'll get more debug messages in the output. So let me enter. So once we enter, then we can see the output here. So let me explain these steps. Connecting to SSH server on port 2222. So this is the port it is trying to connect. The server will offer that remote protocol version is 2.0 and the client protocol version also should match. You can see here local version string is SSH 2.0 and there is a match happens here. Okay, so this SSH match protocol version should match, then only it will go to the next step. So the next step is establishing a symmetric channel. So for that, the client and server agree upon some algorithms. As I explained, they will agree upon like key exchange algorithms, host key algorithm, and MAC algorithms, etc. So here we can see, and the client will propose some of the algorithms. That means what are the algorithms client is supporting. So we can see here the client is supporting these key exchange algorithms. Okay, and also it is supporting these host key algorithms, and it supports this max CTOS means client to server and STOS means server to client. So what are all these like? So here the client is proposing the KEX algorithms, host key algorithms, and corresponding ciphers, the max CTOS and max STOS means client to server and server to client. So all these algorithms, whatever supported by client, will be proposed to the server. Same way, we will get a proposal from server as well. So the server also will support some of the key exchange algorithms, host key algorithms, ciphers, max, everything. So these should be matched. Finally, once the match happens, once the match of at least one algorithms and the ciphers, everything will happen, then the key exchange algorithm, the host key algorithm, and ciphers, all these things will be finalized. So once the algorithms are agreed upon between client and server, the server will offer a host key. So this is a public host key, and this is the host key. So this is not a user public key what we store in authorized keys file. This is for verifying the identity of the host. So once to verify that, we have to say S here. So once we say S here, the public key will be stored in the known host file of the client. So once it is stored, that means the client has verified the identity of the host. That means whenever new connection happens and whenever any further connection happens from client to server, it will first check in the known host file whether the host public key is there in the known host file. Then we do not need to do this step again. So let me say S here. That means the client is verifying the identity of the host. So we can see here permanently added the server entry to the list of known host. That means the server public key is added to the list of known host file. So once the host identity is verified in client, the next step will be the generation of a symmetric key both in client and server, so that the encryption and decryption will happen using the same key. We can see from here, from this step to this step, it these steps indicate generation of a symmetric key and how they share the key between client and server. So once this step is happened, the next step will be authentication. So in the authentication method, there are two ways it will check. One is public key method and another is password method. The first method will be public key. If we don't have any public key in the authorized keys file, then it will go for password approach. So as of now, we don't have any public key of client in the server. Then it will check via password approach. So first it will check for public key. So first it is checking for public key authentication method, but it will not find any private key in the client and corresponding public key in the server. We can see those messages here. So the next method will be password method. So it will ask for the password. So we have to enter the password of the. So let me enter the password. So now SSH connection worked successfully. Now the client is connected to server via SSH. So this way we can see various messages in client, how the connection is happened from client to server. Same way, let me exit from the session. So now we can see the public key method. So let me generate a private key and public key in the client using SSH keygen -20. I'm using an RSA. So now we can see here the ID RSA is a private key and ID RSA public key is a, and this is the public key. So we can copy this public key to the server. So using SSH copy ID, we have to specify the same port and we have to give the user through which we want to connect to the server. Once the password is provided, then it will add the key in the server. We can see the same key inside server. So this is the server machine. Let me go inside. So let me go to the test user. So here we can go to .ssh and we can check here authorized keys file. So we can open authorized keys. So this is the public key of the client machine. So now the public key is copied. Let us verify the SSH connection from client to server again using the same command. So here we are using -vbb, means it will provide all debug messages. Let us verify now. So now it is directly connected. So why? Because we have already have the public key of the host in the known host file, so it will not ask us to enter again. And also we do not need to enter any password because the first authentication method will be the public key method. So we can see those messages from here. So I will explain the same steps what I have explained here. So now let us verify the output here. The first step is trying to connect to the SS server on port 2222. The next step, the client and server will verify the version of the SSH protocol. So both should match. Both were matched here because the protocol version is 2.0. So in the next step, both client and server will set up a symmetric channel. So for that, both will agree upon the algorithms, the KX algorithm, host key algorithm, and ciphers, and MAC, CTOs, etc. So all these client will propose some of the algorithms and server will propose some other algorithms. So both will agree upon the common algorithms. Both has agreed upon some of the algorithms. So once both are agreed upon, then the server will provide a public key. So this is the host key, and since this key is already stored in the known host file before, it will not ask us to store again. So it is verifying the key. It is verifying the key inside known host file. So since it is already there, it will load it from there, and the identity of the server is verified. Since the identity is verified, then both will generate a symmetric key. The client and server will generate a symmetric key, which will be used for encryption of data between client and server. So these are the steps for it. So once the symmetric channel is established, the next step will be SSH, user authentication. So in this process, since we'll have two methods, one is public key and password. Since we have the public key inside the server of the client, so the client is offering public, and server will verify this key, and server will verify the public key inside authorized key file, and the authentication will be succeeded. So since we have the public key, then it will not ask for again password, and this is kind of a passwordless protocol. The server connection will happen without any password by using public key and private key concept. So in this session, we have learned how SSH works in detail via hands-on.